You saw pictures, right?
All right, guys. Any other quick questions from the test? Anybody? Everybody? Any quick questions from the test before we get back into finishing up chapter 5?
Number 7.
Oh, so all right. A few people didn't quite catch what they did wrong. Plus, all right, so we gotta be really careful because we really need to dig deep back into why we do things. So I saw a few people saying, this is number 7, the one with the student making a mistake when they were subtracting. People said a 0 should become a 9, which is not good enough. How can a 0 become a 9? It makes no sense, right? Like a 5 can become a 4 if you take a 1 away from it. So like a 7 can become a 17 if I put that 1 in the tens place. Are you guys with me? All that makes sense. 0 can't become 9. That's some magic shit, right? Now, what I want you to understand is, I know when you're doing these problems, you probably do that, but you probably do the next thing correctly also, because you just know how it kind of works. But what has to happen first to that middle 0 before you can make it a 9? Yeah, you got to borrow from the hundreds to make it a 10, and then you got to borrow from it. So there's a really decent way to explain to the student, they did everything right, except when they put that 1, let me just make sure I know which numbers it is. When they put that 1 on the 6, on that 1's place 6, where did that 1 come from? That's the thing to ask the student, right? And then they'll look back and they'll say, well, they won't say, oh shit, they'll say, oh. Is that, you guys kind of with me? So they made the 0 a 10. Wow, beautiful, fantastic. Then you got to take from that 10 something to make the 7, the 6 is 16. Anyway, so I know we all know this, but we've got to get beyond, we got to get out of the shortcut mode for some of this really basic stuff, because your students are not even going to know the long cut yet. Does that make sense? So you can't build from your own teaching methodology. You can't build off of your own shortcuts. You have to be careful. You have to go more basic than that. Does that answer the question?
Yes.
Okay. Got All right, guys. If there's no more immediate questions, go ahead and put that away. Go ahead and put that test away. Take that test and put it like in something away. Okay. So let's get back into chapter 5. We have one section left to do, and it's going to lead into a section that I know you've been waiting for. Yes. Oh, yes. Right. Getting into fractions means we get to play with this stuff. Ooh. Take Jake with some keys. All right. Andrea, don't worry about it right now. You're okay. You can look for it later.
Okay.
And if you never find it, I'll trust you.
Really?
Yes.
Thank you.
Just, you gotta remind me. But keep looking for it, but right now, don't worry about it.
Yeah.
All right, so let me ask you some questions before we get into specific notes. What does this stand for?
Greatest common factor. Greatest common factor.
I like it. All right. I was hoping somebody would make something else up, like Greek chicken fried or something, but no. It's greatest common factor. How do you find, so for example, how would you find the greatest common factor of 18 and 54. Here, don't say anything. Just take a minute. Greatest common factor. Will the answer be bigger or smaller than each of those numbers? Smaller. What's a factor mean? What is a factor? A factor of a number. What does it mean? It's a piece of that number, right? It multiplies to become that bigger ass number. So the GCF is going to be smaller than at least one of those. It might be equal to one of them. So GCF, normally the answer is smaller than what you're working with. LCM, or LCD, is bigger than whatever you're working with. Okay, I like it. So see if you can find out what the GCF is. All right, so what method did you use?
Me?
Yes.
What divides into 54 and 18?
Sure, but how did you just start dividing each one by, I should have told you no calculator, but did you just start dividing each one by 2, each one by 3 or
No,
something?
I knew that 18 goes into 6, or 6 goes into 18, and 6 goes also into 54.
All right, so 6 divides both. 6 is definitely a factor then, right?
Oh, the greatest. Never mind, sorry.
But yeah, it might not be the greatest common factor. I like it. So what method, who's got some other answer? What method did you use?
You don't want to ask me, I just use my calculator.
What method did you use? Thanks for being honest.
I just like guessed to see if 18 could go into 54.
Yeah, it's not a bad place to start, right? Take the smaller one and just see if it divides in. Why not? All right, and sure enough, another way to kind of, all right, let's talk about some specific ways to do this. And then let me see, which order do I want to do this in? All right, let's do the official, technical, by the book ways, and then we'll talk about some slightly better, more direct ways. Okay, so one method is called set intersection method. All right, and this gets a little insane, but the thing to remember is, and again, just to remind you guys, a lot of what we do in here isn't going to apply to everybody. Does anyone have any idea what grades they would like to teach?
Second or third.
Second or third?
Preschool,
Preschool, kindergarten. I have turned May off to teaching. That's
No, I've been thinking about it before this class started.
all right. I'll try not to be too bad.
Either kindergarten or third graders.
Oh, I like it. Kindergarten or third. I love it. You're like those first and
Also
second.
K
Those
through
are shifty.
6.
Kindergarten, third grade.
Because I kind of want to relate to the kids, you know what I mean?
K6.
Maybe.
Because like,
And then
you
it's
see, I have autism, and I want to make the kid who has a kid with special needs, make them not feel alone.
I see.
And so how can I relate to them if they're too young? And how can I relate to them if they're too older, because they're just past that age, you know what I mean?
Okay.
They are.
All right. Well, as long as you've thought about it and it makes sense what you want to do. Anybody else know what age, what grade they want to teach?
Not middle school.
Yes.
Second or fifth. Second or fifth.
Second or fifth? And what is that based on?
Personal experience.
Oh, okay. All right. I like it. Yes.
K through 6.
K through 6.
Honestly,
If
if
you were
they
going
can
to
put me
teach.
in there, I'll do it.
Yeah. Part of it is kind of like whatever the hell I can get.
Yeah.
I
I
understand.
have in the CIT school district. Sorry,
Okay.
they have a preschool program for special ed, and I would do that because they get the same pay scale and stuff as like normal like teachers, and because preschool teachers do not get paid enough.
This is true. This is very true.
The
So I
teacher,
was,
I'm
sorry, you can go.
I keep doing that to you. Go on.
The teacher that I'm student observing right now for my teaching as a profession course, she wanted second or third, and she was told like for the entire school year prior that she was gonna get second or third. And then 2 days before school started, they threw fifth at her.
Wow.
Yeah,
All
so
right.
I'm like trying not to like get second and third stuck. in my
Considering
head.
teaching is like at least 40% preparation.
Yeah.
2 days before it's crazy. So yeah, I remember back, so I'm a full-time teacher now, but I was a part-time teacher, and when you're a part-time teacher, at any second your class can get taken away from you and given to somebody else. At any second they could say, we just had 3 classes open up, I know the semester starts in a couple days, you want one of them? And I'm like, my bills say yes. So, it could be anything, yes.
What happens if you're like a teacher's aide?
What do you mean, what happens?
Like, what's the difference between a teacher and a teacher's aide?
Teacher's aide?
Well, big one is
Teacher's aide
pay.
right now, you
Yeah.
don't need, associates, you need a high school degree.
Yeah, you talking about the requirements to be one?
Like requirements to be one, cause I know that one teacher said, he didn't have his college degree, but he was getting his master's or something.
I see. Yeah, teacher's aide, the requirements are less. It is sort of locally determined to a certain degree, and the pay obviously would be less. But I don't know if there's any overriding requirement baseline. That makes sense, yes.
If you're in the CFC school district, if you're an instructional special ed aide number 2, there's so many. You have to have your CPR certified.
Yeah,
You should
okay.
be that anyways.
Yeah. I would hope that most teachers would even be CPR certified. Okay. What got us on that? I can't remember now. All right. So the set intersection method, I have some notes. There we go. Where do I want to start with this? Yeah, okay. If I take, 18, 54, and I just start listing, in set notation, I just list all their factors. Oh, by the way, one thing I forgot, that's right. Okay, that's what was throwing me off of my notes. So I want to list all the factors of 18. I'm going to list all the factors of 54, right? Okay, now, little side note about factors. You can actually know ahead of time how many factors to expect from any given number. Does that make sense? Wouldn't that be kind of nice to know?
Yeah.
Like if you're about to factor 68, how many total factors should there be? So you know if you missed one or something, right? Now the funny thing is, all right, so this is a little side note. Ooh, you're new. Whoa, I can smell that through my mask. You are new. Bum, bum, bum. I think I can see that, yes. There we go. Boom. What's 18 broken down? 9 times 2, and then 9. 3 times 3 times 2, so it's 3 squared times 2, right? What about 54? 6 times 9. 2 times 3 times 3 times 3. This is 2 times 3 cubed. Is that cool? Okay, I like it. Now here's what's interesting. Let's see. Couldn't I, like, if I recombine these, I'm going to get factors, right? So obviously 2 is a factor. Obviously 3 is a factor, right? Obviously 2 times 3, 6 is a factor. 9's and so forth. So because of all the different ways I can combine these things, now watch this, watch it. Let's do this. Let's finish. Let's do this, and then I'm going to come back and show you a neat shortcut. Not a shortcut, but still. So what are the factors of 18? Start listing them off for me.
1.
Okay, 1,
2.
2,
3.
3,
6.
6,
9.
9, 18. I like it. So that's 1, 2, 3, 4, 5, 6 factors, right? You with me? Now watch this. Isn't this power is 2, and this power is 1, yes? So what you can do every single time, and this is a consequence of the fact that I'm going to be pairing these things up with each other in all the different ways. If I add 1 to both powers and multiply them, it will tell me how many ways there is to combine them. So sure enough, what's 2 plus 1? 3. What's 1 plus 1? 2. 6 ways. And there's my 6 answers. Maybe. And I want you to realize, do I have to include 2 in one of the factors? Does every factor here have a factor of 2 in it? Does every factor here have a factor of 2 in it?
No.
No, right?
And 9.
No. No, right? Okay. Does every factor up here have a factor of 3 in it?
No.
No. No. Okay, now, what the shit does that have to do with anything, Jeff? I don't know. Oh, yeah. I saw some of your eyebrows go up, and I like that. Does that make any sense as to why this would work? Maybe on the edge of your thinking, you can kind of... So watch this. This is a little further than we have to go. But if I want to put these together, couldn't I have no 2s and no 3s? Stay with me, stay with me. This is more than I thought I was going to do, but I know you can handle this. Couldn't I do no 2s and no 3s? And that's 1. That's always a gimme. I can just do none of them, and that's 1, and 1 goes into everything, right? 1 is the most laid-back number. Then I could have like 1, 2, and no 3s. I could have 1, 2, and 1, 3. I already missed 1, damn it. No, I didn't. I'm okay. Are you guys kind of with me? How many ways can it combine these pieces, parts at a time, right? So the fact that I could have 0 or 1 2s, that's where this 2 comes from. I have 2 options for the 2s. I could have none of them or 1 of them. What about for the 3s? I could have none of them or 1 of them or 2 of them. So I have 3 options for the 3s. Okay, maybe. And then you have 3 options for the 3s. And for each of those, you have 2 options for the 2s. 3 times 2, 6. So how many total factors should there be for this one? What would you multiply together?
2, 1, 1.
You got 2 times 4.
That'd be 8.
So 8. There should be 8 total factors. Is that a relatively easy thing to do? Is it relatively easy to make a factor tree? Especially for us, now that we know how to see real quick if 3 goes into something, or 4 goes into something, or 5, or whatever, yes?
How did we get 6 into the factors of 8? I mean 18, like 1, 2, 3. I mean, I understand the 1, 2, 3.
Oh, this is just, you always have 1 in the number, right?
Yeah.
That's always a gimme. It's even, so 2 times 9 is 18. 1 plus 8 is 9, so 3 goes in. 3 times 6 is 18.
Oh.
And then 4 and 5 don't go in, and then suddenly I'm at 6, so I've already started to kind of go back on myself.
Yeah, okay. Now
So this is just making a list like we know we can do, but you guys know it's really easy to forget some. It's really easy to miss some factors, yes?
Yeah.
So isn't it cool to have a way to know exactly how long that list should be? So you can quickly see if you missed some. So now we know this is supposed to be 8 long, yes? 8. 1 plus 2 is 2. 1 plus 2 is 2. 1 plus 1 is 2. 3 plus 1 is 4. Multiply. So I know it's supposed to have 8 pieces. So there's the gimme. There's the 1 and the 54. What else?
9 and 6.
9 and 6. I like it.
2 and 27.
2 and 27. I like it. It was even, so I know 2 goes in.
And 3 and 13.
3 and 14. 18. I forgot what number it was. Do we have all of them?
1, 2, 3, 4, 5, 6, 7.
4, 4. Yes. Yes. Okay, I like it. Okay, not bad.
Is this related to 5.2?
It's 5.2.
Yes, this is 5.2. Yes. Sorry, we're finishing up chapter 5, so yeah.
Okay.
This is all 5.2. Oh yeah, that's right, because you looked ahead and you're like, what the hell is this? So we're finally
Yeah,
getting there. Yeah.
then like the last week you mentioned that we are not studying 5.2. I was just wondering on the day last week if we were supposed to turn
No,
in
you're good.
5.2. Yeah.
Now you can start officially working on it.
Okay.
All right, guys. So we're obviously not done here, right?
No.
We got to find the GCF. What is the So if you look between these two, what's the intersection?
One. Wait, just one. Are you asking for like one or multiple numbers that intersect?
The intersection. This is something we studied before. So what is the intersection? What is in the intersection? The intersection is everything that is in both.
There's 1,
One,
2, 3,
two,
6, 9, and
6,
18.
9, 18. Yeah. Is that cool? You guys with me? We're kind of combining some things we talked about before this semester, earlier this semester, right? Intersection? Yes.
I'm still confused on the 2 plus 1 and the 1 plus.
Okay. Are you confused about why it works? Because, so if you, all right, so this isn't why it works, but this is a second power, this is a first power. So you can always add 1 to each power and then multiply. Now, I really want to make sure, I really want you to understand why this is true. So let me try this again. So this fully is 18, right? 2 to the first times 3 squared is 18, right? Okay. But could I do 2 to the first times 3? 1 3, right? So that's 6. Could I do 2 to the first times no 3s? That's 2. Could I do 2 to the 0 times 2 3s? Could I do 2 to the 0 times 1 3? 2 to the 0 times no 3s? Isn't that all of the factors, right? All right, cool. And I'm sorry I stopped earlier because it felt like nobody was really questioning why it worked, but that's where I was going with that. So what is it? So again, there are 2 options for the 2's, right? You could have a 0 or a first power. And for each of those, there are 3 options for the 3's. Yes? You could have a 0, a 1, or a 2. 2 options for the 2's, 0 or 1. 3 options for the 3's, 0, 1, or 2. So I always add 1 because I'm counting the 0 power as an option. I really want that to make sense. So if I see a first power and a second power, there's really 2 options, and there's really 3 options. And you remember the tree we made? Remember the tree with the car, and you have the exterior color and all that kind of stuff? Well, if I have 2 options, and for each of those I have 3 options, isn't that going to be 3 times 2 is 6? Okay. All right, I like it. Now, this one seems very like it has too many steps. Steps here are not necessary. But again, we are discussing this with students who don't know any of this, right? So the answer is going to be the largest number in the intersection. So we get 18 again. Right, that's the answer. That's the GCF. That's 18. Why does that make sense? Because, and in fact, how could you what's the immediate thing you can do to cut down on how long this is to do? Do I really need to write the whole intersection? Couldn't I just look at these 2 and see the biggest number that's in both? Okay, I like it. But if you do this, you're reinforcing the idea of sets, you're reinforcing the idea of intersection. You guys with me? Okay, I like it. Any questions about that so far? All right. So here, do this that way. There it is. So for what do you got, Jeff? 20. Write a number. There's a number. 28 and 70. Find the number of possible factors for each. Right? That's where you do the powers. And then find the GCF using this method. Enter what, Jeff? What language is that? Okay. Using set intersection. have to move you back, I think. Will you be all right? I think you'll be all right. Yep. I'm going to start to catch up to you guys. Should be 6 factors here. This was a neat one here. Do you guys realize what to do here? So you have 3 parts. 1, 1, 1. 2 times 2 times 2.
But why 2 times 2 times 2?
Because now, all right, all right, here we go. The ultimate explanation. When I start, let me see if you guys really understand. Does everybody really understand that if I take any combination of these, I get a factor, right? So 2 times 7 is 14. So 14 is a factor of 70. Is that an obvious factor of 70? If I said, give me a factor of 70, how many of you guys would go, 14? It's not obvious, right? You guys would think. Why does it make sense, though? Because 7 goes in and it's even. 7 times 2 should, anyway, sorry. Stay with me. So watch this. So couldn't I do 2 times 5 and not use 7? And that's 10. 10 is a factor of 70. Is everybody with me? Or I can do 2 times 7, I can do whatever. So here's the idea. Let me see if you guys are really with me. So do I have to use a 2? Couldn't I use either no 2s or 1 2? Yes? Yeah. Couldn't I then use no 5s or 1 5? Okay. And then couldn't I then use no 7s or 1 7? All right, what the hell is all this shit mean? This means, for example, no 2's times 5 times 7, 35 is a factor of 70. Does everybody agree with me? Of course you do. So if I just do all these, I get all the factors, right? And sure enough, how many factors do I get? 1, 2, 3, 4, 5, 6, 7, 8. Of course I get 8, because I got 2 times 2 times 2. Okay. So if I had one piece of wood and I chop it, how many pieces of wood do I have now? 2. So it's kind of like I keep chopping. I had 1 and I chopped it into 2, and then I chopped each of those into 2, and I chopped each of those into. Of course I got 8 now. Okay, maybe. So what's the shortcut? Raise each power by 1 and then multiply them all together. Okay, like that. Yes?
For the branching off and stuff, how do you pick what numbers you're gonna put?
Oh, did somebody else break 20 up in a different way, or
14 and 2.
Yeah, that's where I kind of got stuck.
you did 14 times 2,
Yeah.
and then 14 is 2 times 7.
Yeah. So
Right?
it's 2. I just did 7. I just flipped 7 and then 2 squared.
Yeah, I really want you to understand. I don't care how I start. If I took an engine and I started to take it apart, couldn't somebody next to me start to take it apart in a different order? If we took it all the way down, wouldn't they end up looking exactly the same? If they're the same engine? Maybe. So if I had a little toy and my little brother had a little toy, and it's the same toy, and we started destroying this toy, but we destroyed it in a different order. If we got it all the way down to all its parts, they would both look the same. So you guys, you said you started 28 off as 14 times 2, right? Isn't 14 2 times 7?
14 times 2.
So don't you still get 2 squared times 7?
Yeah. I just did 7 times 2 squared, which is 6.
Oh, I see, yeah, same.
Okay.
That's why I call this the DNA of the number.
I zoned out. How'd you get 3 times 2 equals 6? I know that's how many factors go into 28, but I'm not sure where you even got 3 from.
I'm trying to get over the fact that I'm putting you to sleep. But the shortcut to this is to just add 1 to each of the powers. What does that have to do? Because if I have 2 2's, I could use both of them, I could use one of them, or I could use none of them. So I have 3 options. 3 options for the 2's, 2 options for the 7's, because I could use the 7 or not. So you always got one more option than the power shows, because your other option is to not use any of them. And what do I mean by that? Couldn't I take 2 times 7, 1 2 and a 7, 14. That's a factor. Couldn't I take no 2's and a 7? 7 is a factor. So we're talking about what is the most fundamental way to create factors. One way is to break it all the way down to its prime factors and start putting those things back together in parts, leaving some out. Then you get this factor, this, yes?
What are the numbers at the bottom of 70? The 3 at the bottom.
Here?
And the parentheses, 2, 4, 8.
Here?
Yes.
Oh, again, what's the power here? 1. So I add 1 to get 2. Add 1 to get 2. Add 1 to get 2. And then multiply these together.
Gotcha.
We should get 8 total factors. What's up?
Now I know where you got the numbers from.
Okay. I like it. And again, now I know how long the list of factors should be for each, which is a good thing to know ahead of time. So what are the factors of 28?
1, 2,
4, 7, 14, and 28.
And then we predicted there would be 6. And sure enough, there's 6. What about for 70?
1, 2, 5, 7, 10, 14, 35, and 7.
1, 2, 5, 7, 10, 14, 35, 70. And this is going to be 1, 2, 3, 4, 5, 6, 7, 8. 8 like we predicted.
Can we get another one?
Huh?
Can we do another one?
Are we done yet?
Because you're
No, I'm not done yet.
Wait,
Shit.
That's not what I asked.
I'm sorry.
That's not what I asked. I
What's
just
up?
asked if we could practice another one.
No, yes, we can.
Oh, okay.
I'm sorry.
I was
sorry.
like, I wasn't being rude.
No, I'm not. I'm sorry. I just want to make sure you understood that we're not done. All right, so what do I do next to figure out the GCF?
Oh, okay, yeah.
The east part. 14.
Yeah, I just find, so we can kind of truncate this, we don't have to write the extra, but the intersection would be, what would the intersection be?
1, 2, 7, and
1, 2, 7, 14, said with the appropriate enthusiasm. And then the biggest one is 14, so that would be the GCF.
Forgot about that part.
Okay. No worries, no worries. Again, doesn't some of that feels unnecessary, right? But again, I do not envy you. It's already hard enough for me when I'm teaching a college class that I have to kind of like ignore a lot of stuff I know, depending on what class I'm teaching, because they don't know this shit. So I gotta, and that you guys have to ignore, like even to a lower level. And you gotta realize, some of the steps you think might not be, or like, why would I? They need it. They desperately need it, right? Okay, so that's set intersection method for finding GCF. So you want to do one more example? Let's see. Like, do you mean an example of this? I mean, is that part okay?
Yeah, that's fine.
This part's okay, right?
Yeah, that's the easy part.
This is the stuff that you're kind of familiar with. This is the new thing.
Yeah.
Okay. All right. Let's see. I'm gonna erase this here.
Yeah.
So see how many factors. Holy shit, Jeff. How many factors would, what do you got, buddy? You can do it. Write something. Ooh, there you go. You're doing it. All right. How many factors would 108 have? So I don't know. I don't care what they are. I just want to know how many should it have. What is the? So I'm always curious, and this is a really good example of a problem that I could have on a quiz or a test where I say no calculator allowed, right? Sorry. That's the other thing. We don't offer evil laugh class here, but you can kind of work on it yourself, develop.
Just go to theater.
Yeah, I was, so this is the most interesting part right here is, somebody tell me what was the first thing they wrote.
I wrote 2 and 54.
I like it. So one option is 2 times 54.
And then 54 times.
Oh, wait.
And then
Did anybody else start off a different way?
36
6 and 18.
Oh, let's see. 6 times 18. That's a neat. And you said what now?
36 and 3.
There's also 4 and 27.
4 and 27. Okay. So we get the idea. A lot of different ways to start off with, which kind of talks about these are all different ways that the real parts can be put back together. Right? So this is like me tearing a doll apart and taking his head off. And then my brother takes both arms off. We're just tearing this thing apart in different order, and that's too bad. Just have fun with that. All right. Yes, sorry. Somebody have a question? Yes.
154 wouldn't it be 2 times 27?
Totally. But do you understand what my point was here?
That's
Somebody else did not write 2 times 54. They wrote 6 times 18. And that is correct so far.
They're all.
Somebody else wrote 3 times 36. Right?
Mhm.
Somebody else wrote 4 and 27. Yes. Okay. But let's see. So like you said, what'd you say?
54 is 2 times 27.
Good. There's the 27 times 4, right?
Yeah, and the 27 is 9 times 3.
And can we get to the point where we know 27 is 3 3s?
Yeah.
So we can just write that?
No.
Okay.
Is that cool? Isn't that what everybody got?
Yeah.
So this one would be 2 times 3 times 9 times 2. And 9 is 3 times 3. So you get 2 times 2 and 3 times 3 times 3. So you still got 2 squared, 3 cubed.
And 9. Would you put the 9 there?
Why?
Is that where I flipped up?
No. You got it. The 9 is here.
Oh, okay.
Okay, I like it. The 9 is there. It's just I tore it apart. And I go 3, 36. So any way you do it, you end up with this is the DNA. So how many factors would it have?
12.
Yeah, because what do you multiply?
4.
Yeah, 4
And 3.
times 3. So there should be 12 factors when you finish.
Thank you.
You're welcome.
I have.
Has anyone ever seen that before? I'm getting the idea that no.
I know, I definitely know 4, but I don't get where the 3 came from.
Well, wait. How could you get 4 when? All right. Where did 4 come from?
Because you added the exponents.
Added what I added 1 to this.
Yeah.
Got 4. So what do you get when you add 1 to this?
That'd be 3. Oh.
So you add 1 to every exponent, and then you multiply them all together.
Oh, okay.
See, I've seen it like that. I just haven't done like the economics.
I'm with you. Guys. And it's not a normal thing that we show, to be really honest, for whatever reason, is how to find how many factors there should be.
Uh-huh.
You guys all right? All right. Okay. All right, so that's the set intersection method with this little extra thing about how to figure out how many factors it's going to have. So there's another method for finding GCF.
But then what is the GCF of 108?
You didn't give us.
Well, there can't be a GCF of one number. It's got to be GCF of 2 numbers, right?
Alright.
Because the GCF would be greatest common factor, the biggest number that divides into 2 or even 3. I can ask you a GCF of 5 numbers if I felt like it. I know. So. Okay.
Ryan?
Now the other method is kind of funny to me. So, guys, there's a little bit of overlap between the methods. A lot of the methods start with breaking them down into prime factors. So if I wanted to find the GCF, what was the first one we did?
It was
18 and 54, right? Yeah. So if I do, so this is called the prime factorization method. And this is where we kind of look at these more directly. This is getting a little more sophisticated. So 18 is, just to cut to the chase, is 2 times 3 squared. 54 was what now? 2 times 3 cubed.
Mm-hmm.
And if I just look at these two, what is the most that they have in common? What is the most that they both have? Do they both have a 2? Yes. Do they both have 3 3s? Shit. No, they don't both have 3 3s, right? So the most they both have is a 2, and how many 3s? How many 3s do they have in common? 2. I like it. And of course that is 18, right? And that's the same answer we got earlier. What's up?
No, that's weird how it was. You're right.
Was it like magic?
Yeah,
David Blaine?
yeah.
Well, I can levitate, watch. You so I can do this. Okay. All right. Is that all right? That's a little more. That's a lot more direct than the set intersection method. But do you understand how this requires a higher level of? Well, not really. But maybe it does. It's just a different way. I really want you guys to understand what just happened, though. This one's almost too easy because 18 is already a part of this. So what if we do what else? What you got, buddy? Let's do 20 and no. Let's see. 20 to 45. All right, what's 20?
5 and 4.
Yeah, so it's 2 squared times 5. Is that cool? And what's 45? Yeah, 3 squared times 5. Is that cool? All right, that was pretty obvious, hopefully. What's the biggest thing they both have? Did they both have a 3? No, did they both have a 2? No, what's the biggest thing they both have? 5. I love it. 5.
Whoa.
So 5 is the GCF. Okay.
Nice.
So it's very direct. It's just asking, breaking them all the way down and saying, oh, what's the most they have in common, right? Okay, maybe. I wanna, yeah, let's see. Oh, this is so cool. All right. Do you guys remember, real quick, how far apart are these? How far apart are these?
36.
36, okay. I don't know if you guys remember this. I'm pretty sure I said this, but let me see. The only possible common factors between them have to be a factor of 36. Because of the way we count. So like, start counting in multiples of 3. 3, 6, 9, 12. How far apart are they all? 3, right? How far apart are 3 and 12? 9. So a common factor must be a factor of 9. Because any factor of 9 would tell me how many multiples I've gone, how I'm counting by 3s. I really want this to make sense. So if I start counting by 18s, 18, 36, 50, holy shit, right? If I start counting by 18s, and that's why 18 was the GCF, is because 54 is a multiple of 18. Maybe. How far apart are these? 25. So the answer has to be a factor of 25, and our answer was actually 5. Yes? Stay with me. Okay. So what if I do one that, let me see. That was a difference of 25, yes? Isn't this also a difference of 25? But can somebody just tell me what the GCF is? Isn't it 25? Because 25 goes into both. Okay. So. Here's a little theorem. Here we go. Let me throw a theorem at you. You're right, the same way they got it. If A and B are whole numbers, and which one did they make bigger? Where'd you go? There's A greater than or equal to B, then what was it? Yeah. Oh Jesus. Oh crap. What the shit? This pretty much captures what I was just saying. So let's try one of these a different way then. So what does this thing mean? It means if A and B are whole numbers and A is at least as big as B, then the answer to this question is the same as the answer to that question. What's the only way I can make a GCF problem kind of gross? Is if I give you numbers that are, is the GCF of 10 and 24, is that difficult? Is the GCF of 578, 882
Yes.
difficult? Yes. So it gets harder when I give you numbers that are bigger. Okay. This theorem is basically coming right off of what I was just talking about earlier. It says that if I'm given a problem, I can just subtract the two damn numbers, which, why does that make it better? Because now my numbers are freaking smaller, right? So look at this. Let's try it over here. So supposedly, so we already know the answer to this is 5. But this theorem says the answer to this is the same as the answer to this. Which, and of course, what do? I would take the bigger one minus the smaller one. What's 45 minus 20? 25. And keep the smaller one. Now I could do it again if can you already see it's 5? Right? But if I do it again, 25 minus 20 is 5. Right? This is definitely, answer is definitely 5, obviously. Right? This is the only thing that goes into 5. I could keep going if I wanted to, but that's what this theorem says. So when is this theorem really going to be useful? Well, what if I had freaking, let's see. Do I want to do this one? Sure. What was that I just said? I wish I would have paid attention to what I just said. 560 and 810. Okay. Oh shit. It just got real. So what can I do? Yeah, so anytime I got a GCF problem where I'm like, man, those numbers are way too damn high, I can actually subtract them because, again, I really want this to make sense. Factors are related to counting by a number. So 3 is a factor of everything that I can count by 3, 6, 9, so forth. So this idea of taking the difference between two things is kind of like catching that idea of the distance between them has to be related to that answer. Oh, I love you guys. Oh, you're all like, oh, Jeff.
How do you know which one's B and which one's A? If it's which
To be really honest, all that matters is when you subtract the smaller from the bigger, right?
So when it says,
Keep the smaller one?
and
Keep
then
the smaller one.
you want to keep the small.
Because the whole idea of this thing
Oh, okay.
is the fact that it works, but to make it really work better is I keep the smaller shit every time. So what do I get when I subtract 560 from 810? 250. So I'm going to keep 250 and 560. Does that look good yet?
No.
No. So I do it again. 560 minus 250.
310.
310, and I keep the smaller one. Let's keep going, right?
60.
Okay. GCF, 60, 250. Yeah, 60, 190.
No, we're going backwards now. Right?
What do you mean?
30.
Going backwards. We're getting better and better, aren't we?
Yeah.
60, 130. Now, do you guys agree with, doesn't it feel like there should be a shortcut to this?
Yeah.
Okay, we're getting there. We're getting there. I want you to understand this. And tell me, all right, if I subtracted 80, how do I say this? I'm sorry. Okay, I'll figure out how to say it in a minute. Let's finish this up. So then I can still do it again, right? 60 and 70. And what's the obvious answer there? I like it. I like it. Every time you give me an answer, it's got to be sung now.
I kind of already figured that though, because they're both 10. I don't know, 160. I don't know.
What's happening? Sorry.
Is the greatest common factor? Did we figure that out yet?
Yeah, we just did.
It's 10, right?
It's 10.
I said I kind of figured it was 10 because honestly, I really don't know why I thought it was 10.
Well, they both end in 0.
And 60 and 10, I don't know.
They both end in 0, right?
Yes.
So that's not a bad guess, but why, maybe it's 20, maybe it's 30, maybe it's 40, right? So 10 is not a bad guess. So don't feel like weird that you kind of knew what the answer was, but to be honest, you weren't sure. When I got down to here, then I'm really freaking sure. Right? But the theorem is all about the fact that this question, the answer to this question is the same as the answer to every one of these questions. That's the trick. So I can keep going until I'm like, okay, now I can see the answer. Now, let me ask you this. All right, this is going to seem like a very unrelated problem. How do I capture this? Oh, yeah, I guess I can do it. Okay. 560 goes into 810 how many times? Once. And then what do?
Remainder.
Yeah, you subtract 560, correct? What's the remainder? Isn't that what we just did? Isn't that what we did here?
Yeah.
What is repeated addition? So what is repeated subtraction? Isn't that one of our algorithms? Isn't it division? Isn't this theorem all about repeatedly subtracting? But not by the same thing every time, right? But still, now watch how this is going to work. So my remainder is 250. Now the neat thing is I take my remainder and put it into this guy. That kind of relates to where we are here. Right? How many times does 250 go into 560?
One.
Once. And there's my 310. Okay, maybe. So that's not going to be really, I happen to pick some exceptionally gross numbers, even though they're both really round. This division would make this quicker if I could do it many times, right? If it went in multiple times. So let's do an example where that happens, so I can really show you. So this theorem is valid on its own. The division approach is just sometimes a shortcut. So let me show you when that would be a shortcut. Okay, I already saw this. Thank you. I remember there was one class where I'd get to like right here, and the same girl made, wait! Oh, shit. All right. All right, I think I have a good one. Yeah, let's do this one. What about, Jeff. Oh, yeah. Yeah, now we're talking. Now we are discussing things.
I just mad.
Okay, so to do it the new way, that kind of builds off that theorem of repeated subtraction. Now think about it. Wouldn't I do 3432 minus 840?
Yeah, but
And then I would get a big ass number still. So I'd subtract 840 again, and again, and maybe again. And maybe again, I don't know. So
I like the other shortcuts better for the first one.
if we do this, can somebody just tell me what you think that is?
1.
8 goes into 34 how many times?
4.
4. It's a good guess, right? You guys see that?
Yeah, because it's 32.
Yeah. So let's see, 0, 6, carry the 1, 33. Is everybody with me?
Yeah.
Okay. So what does this represent? How many times would I have subtracted 840? 4 times. And now I'm going to see what would have been left.
72. I think.
Yeah, 72. So then I would have 840, comma 72. You guys with me?
Uh-huh.
I really want, you guys really with me?
Yes.
Okay. So I wouldn't really write this, but I would have 840, comma 72. And then I would just do this again. 72 into 840. Goes how many times?
11.
With
48.
48. Okay. So now I would have, what would you have, Jeff? You would have 48, comma 72. So now I divide 48 into 72. All let me stop for a minute. You guys don't have to stop, but I'm gonna stop for a minute. Is this like a definition of division or something? No. This is us using what division represents in a creative way. I've got to subtract something, possibly multiple times. Well, why don't we divide then? That's a shortcut. Repeated subtraction is division. 48 goes into 72. Once. $24. Right? Then I would do 24 into 48. How many times? 2 times, right?
Wait, but how did they get that?
I don't know. So then what does that mean? Yeah, because this would be, what would this be? This would be GCF of 24 and 48. So the minute you get one that goes in evenly, then the last thing you got would be the answer. Because now 24 goes into 48. So what is GCF? It must be 24. No, careful, not 2. 2 24s make 48.
Yeah.
So what is the GCF of 24 and 48? 24 is, because that goes into both. I can feel you guys not liking this. Let's do this process, but with smaller numbers, so we can really follow along, okay?
Yeah, because this process is spinning my head around.
I understand. Let's do it with smaller numbers so we can really see what's happening.
Oh.
Maybe? Because let me ask you a weird question. Does this make any sense? All right, what's the GCF of 24 and 24? Whoa.
What?
You can do it. What goes into 24 and it goes into 24? 24.
Yeah.
You can always divide a number by itself, right? Always. Yes? So in general, what is the GCF of A, comma A? Freaking A.
Wait.
You guys okay? Is that almost time? No. All right. Okay, maybe. But what does that mean is true then about this? This is a weird question. It would be A. It would be somebody doing the subtraction thing one too many times. I really want that to make sense. So this doesn't really make a lot of sense, but the answer here is by definition A. Because isn't A times 0, 0? So therefore A is a factor of 0 in a sense. So 0 is that weird dude that has every number as a factor of 0. All right, I'm just trying to make sure you understand. We got a remainder of 0 here, which is kind of like going one step too far. So that's why the answer was 24, because 24 goes into both 24 and 48. Maybe. All right, so let's see. Maybe we should do a shorter, smaller number problem. Let's see. So what about GCF of 12 and you could do it, Jeff. Let's do 12 and 52. Sure. So I'm going to do it 2 ways. Right? So I could do 52 minus 12. Right? Is everybody with me? Right? That's just the subtraction theorem thing. All right? And then I could do it again. 40 minus 12. Yes? And then I could do it again. 28 minus 12. And then I could do it again. 16 minus 12. Do I need to do any more? No. Because what's the GCF of 4 and 12? Frickin' 4. Yes, okay, I like it. Okay, maybe. Now, what if we do the division way? 12 goes into 52 how many times? 4. 4 times 12 is 48. So look here, how many times did we subtract 12? 1, 2, 3, 4. Yes? Yes? That's what that 4 means. Didn't we just subtract 12 4 times? Didn't we? Isn't that what that 48 is? Isn't that 4 12s being subtracted? All this is this. So what's the remainder here? 4. So do you see how we're here now?
Yeah, I can see it now. Yeah, I can see it now. It totally makes sense.
So that's how you interpret where you are when you're doing this. This means 12 4.
So the greatest common factor is 4.
Yes.
Cool.
I like it. Because, and again, just to go one step too far. If I do 4 into 12, it goes evenly, yes? No remainder, yes? Which means the last thing I divided by is the answer. Because that is the multiple that fits in there. If I step by 4, okay, maybe. Man, I've lost what happened? Oh man, everybody had to go take a nap, I understand. Jeff is just being boring today, I'm sorry. Thank you, I appreciate it. You're here and currently awake? Okay.
I'm not awake, but thank you for assuming.
You're a high functioning sleepy person, I'll tell you. All right.
I beg to differ that.
The fact that you put together a phrase like I beg to differ says otherwise. All right, so.
Anyway.
That's kind of nice. Okay, let me throw this away. This is really important, by the way. You're going to have a really exciting time.
Thank you.
This is in general the way I try to teach. Is you've got to lay the groundwork out. Students are always kind of upset when I teach them the shortcut. But then I try to remind them the shortcut would have made no sense if I was showing you that first very often, right? So some teachers just teach the shortcut, and that just drives me insane, because then the students have zero connection. They're just like, the guy said to do this, so I do this, right? Have you ever felt like that? Okay, so you guys are going to be better than that shit, right? You're going to try to show your students, here's the basis, here's what this, and then like, well, what can we do to make this quicker? You know, you want them to have suggestions or at least come with you. Well, how can we make this quicker? We can do this. Do you think that would always work? You know, that kind of thing. Okay, maybe. All right. Bum, bum. Did I do all that? Yes, I like it. So last thing for today.
Blocks.
Last thing for today.
Oh my gosh.
Damn. All right. I got so much today. I gotta try to not take too personal. What is LCM?
Common multiple.
Is that what you're gonna say? Yes, good. I like it. So LCM is least common multiple. It's also known as LCD when it's involved in fractions.
Sounds like a new one.
Okay. So there are 3 methods to figure out LCM officially by the textbook, right? 3, Jeff? Yes, 3. And again, they kind of overlap a bit. Yes?
So the textbook uses LCM instead of LCD.
Okay, I really want this, guys. LCD is a specific use of the idea of LCM.
Oh.
LCM is the bigger idea. LCD is LCM, but it's when the multiples are in the denominator, so that's why we call it LCD.
That's a fun answer.
I like it. I want it. Sorry. I was just saying we could have called it LCM in the D, but that would have sounded very strange. Least common multiple multiple in the denominator, but
Terrible.
let's not do that. Yeah. Maybe that was thrown around and they said no, and thank God they did. Okay. So, for example, how would I figure out the LCM of, what is it, Jeff? 18 and 12. Sure. Before I show you the textbook ways, what ways do you already know?
Multiply them together.
Okay.
Right?
Why would that not give you necessarily the L?
Least.
See.
That's what I did with the grade.
Well, the greatest common multiple is
The
always
last time we did
infinity.
a 6, I got 6, and that's not the greatest.
Listen,
I know like one of them we had. I remember.
All right, watch.
multiply the
Watch.
two together.
What's the LCM of 9 and 2? 18. Done. Yay. Why is it okay to multiply 9 and 2 together?
Because they're already small.
Because 9 and 2 don't have any common factors. What did you say? I'm sorry.
She was
No, I
caught.
was just mimicking you.
She's doing
No, she was
She was like,
mimicking you.
she was whatever you're
doing.
She was like, I knew that.
All right. So watch this. All right. Stay with me. This is a neat way to do this. Can somebody tell me what is the biggest number? What is the GCF of 18 and 12? 6, yes. All right. Now, whoever said to multiply, what is 18 times 12? $216?
Yeah.
Okay, I'll trust you.
I'm doubting myself.
I don't know. Yeah, okay. And what is 216 divided by 6?
36.
36, okay. Now, keep this in the back of your brain. Can somebody tell me, how do you figure out the LCM? So again, just to kind of really freak you out, if I had to do this problem, I have to do what this is asking, right? I have to find the least common thing they both multiply up to be, right? That is what LCM means. And when we see this, we either, one, freak out, or we, two, think exactly what I just said. What can I multiply them up to be so they're the same? That is what this means. So what method do you use? The most basic method we use is to just make a list of multiples. So 18, keep going for me. 36.
What's next? 54, is it?
54, like, all right, blah, blah, blah. Now do 12. 12? 24? 36, I can stop, right? Isn't that, hey, look. I know, I don't blame you. So do I. But I just want to show you, this is the connection.
Thank you.
What is the greatest common factor of these? 1. So then I would divide 9 times 2, I'd divide that by 1, that's why the answer is just that. Whereas this one, if I do 18 times 12, I am multiplying 6 more than I needed to. Isn't 6 in 18? And 6 is in 12. Didn't I already have a 6 from 18? So I'm dividing the extra 6 out. So this method does work.
All the time?
Yes.
Cool.
If you can find the actual GCF, listen, if you can find the actual GCF between the two numbers, and then multiply them and divide by the GCF, you have the LCD, or the LCM, whatever the thing is you're looking at. You guys understand that? But that's funny to me that that's never really shown to students. There's this, now let me throw this term at you. I don't get to say this much to anybody. Relatively prime. Listen, stay with me. Is 9 prime? Is 9 prime? No. Now listen to what I'm about to say. 9 and 2 are relatively prime.
Why?
Because they don't share any factors. They don't share any factors. What about 18 and 12? Are they relatively prime? No, they share a bunch of factors, don't they? I'm sorry. You don't have to know the phrase relatively prime. It's just one of my favorite little things. And you're all like, dude, my favorite things are puppies, and you're talking about relatively prime. Something is wrong. Okay. It doesn't mean that you married into Optimus Prime's family. I'm sorry, that's a horrible joke. I kind of liked it.
It's a false joke.
Relatively prime. Okay. Terrible joke. I don't give a shit.
Marriage and it's his father-in-law?
Optimus Prime. Relative to prime. Yes.
Will we need to know relatively prime for?
No, of course not. No. Okay. Maybe I'll do a bonus question now, but yeah. It could be better than the one I was thinking about doing. Okay, so this is actually one of the official methods here. And not surprisingly, this is also called set intersection. So I make a set of multiples of each, and then I see the intersection with the smallest number. You guys with me?
Yes.
Yeah.
Hello?
Yeah, we're all here.
No, I know you're all here. Some
We're
of
not
you,
meant to live here at all.
some of you are
I physically met.
in conversations about other things. Okay. There's also this method, which is my personal favorite. So same question. Break 18 and 12 down. What do you get? So we've kind of done this one before, right? This is 2 times 9, so 2 times 3 squared, is that cool?
Yeah.
And what's 12?
3 or 4.
3 and 4, so 2 squared times 3, is that cool? Now watch, this is kind of cool. I love this method. 12 and 18 are kind of simple though, so this method's almost too much for 12 and 18, but I'm talking about when you get some freaky ass things. Does anybody in here, I don't know, nobody in here's really, well, I don't know, anybody have kids or
We
kids,
all
8
spent the
kids?
first day and she's gone.
Sorry?
Is it?
Oh, that's right. Okay. I don't have kids either, which is probably good because my example is always if you give 2 kids bowls of ice cream, and I did used to be sort of a dad with a couple kids. We're no longer, so. But if I give 2 bowls of ice cream, there's invariably one of them is going to say, "Well, she got more." You know.
Yeah.
All right. In which case, I would just say, "I eat all the ice cream. Get away from me," and that's probably better than So like I gave sprinkles to one and not the other one. So how would I make that fair then? I would give sprinkles to the other one, right? So look at these bowls of ice cream. That's what these are. Why is this kid upset looking at this kid's bowl? What did this kid get that this kid didn't?
4 twos.
Yeah, he got more 2s. What the shit, right? Well, hopefully they'll look at what the shit. Stay with me now. So, wouldn't he want, what does he want? He wants 1 more 2, yes?
Yeah.
He wants 1 more thing of sprinkles. Okay, so I give him a 2. Why is he upset?
Yeah, 3.
Yeah, so I give him a 3. Now, are they both the same?
No.
Are they both the same?
I can't tell.
Because of my writing?
Yeah.
I'm sorry.
Yes.
Okay. So this is 2 squared. This is 3 squared. This is 2 squared. This is 3 squared.
Yes.
So now they're both the same, which is the whole idea of LCM is what's the smallest number you can get them both to be. So what is the LCM then? What is 2 squared times 3 squared? What is 2 squared times 3 squared?
9. Wait, what?
What is that? 4 times 9?
36.
Which is the answer, right?
Cool.
36.
Go team. What is happening? Alright, so last problem, then we'll head out of here. We'll head out of here a little early because some of you guys left about 45 minutes ago.
Wait, what is that called?
Sorry?
What is that method called?
Oh, what does
The
the
little
book
tree
officially call this? Oh, the book calls this build up, which makes sense. The build up method. You build on top of this, right? And you build on top of that. You build them both up to be the same thing.
Very creative. Okay, thank you.
You're welcome. So let's try that build up method on these 2. What do you got, Jeff? Oh, Jeff, what do you got here? Oh, jeez, I don't know. Sure, why not? Oh, I like that. That's nice and gross. Those are bodacious. What are you talking about? Bodacious.
That's light.
What are you doing in your head?
I don't know what we were doing. Are we doing the first method?
We're doing.
Oh, that method.
Yeah, no, that method, yeah. This method, I'm pretty sure all of you guys are very aware of.
That's my favorite.
Yeah.
I know that.
Can you imagine doing this method with that though?
Oh.
Okay, that would sort of suck.
Oh, yeah.
Louis, your reactions are making my day.
I got you.
So I'm gonna probably do this different than some of you guys, but we'll end up at the same place at the end. This one's neat.
Yeah.
Let me stop for a minute. And again, I kind of took less steps and I probably started off the different way, but what matters is, do we agree at the end?
Sure.
I love it. Sure, math boy. Alright. Now, here's the build it method. Why is this child upset?
Because it has.
Less 5 and less 2.
It has less 2's and
A 3.
a 3.
I'm missing a 3.
Alright, so I'm gonna give it,
You have fun again.
let me do this in different color. I'm gonna give it, how many more 2's?
Two more.
2 more 2's, and I'm gonna give it a 3. Why is this child upset now?
Because that one has.
I mean, look at all the shit this
Don't
kid
have
got.
a 5.
Yeah, what's the only thing this guy's missing?
A 5.
Just a 5, yeah. So now they both have 2 to the 5th times 5 times 3. Let me stop, let me stop. Let me stop. Yes, yes.
I got, for this one, I got a different, for 96, I got 248, but then I got 2 times 24 to get the 48.
Sure,
So, and then I got 2 and 12, and then I got 6 and 2, and then I got 3 and 2.
sure.
So
Now collect, how many 2's do you have?
that's 2 5s.
5 2's.
Yeah, 5.
And a
2s.
3 and a 5, right?
Yeah.
Okay, so we ended up in the same place.
Oh.
So again, it doesn't matter the path you take to get there, we're gonna have to end, because this is the DNA of 96.
Yeah.
Go.
Okay.
Yup.
You doing okay?
So what is the least common multiple?
We're getting there, we're getting there. That's the answer.
480.
What that's?
But I'm waiting for somebody to tell me.
480.
Sorry?
480.
480?
Yeah.
Okay.
480.
480.
Yes, it does.
Just 60 too much. All right. So we cool with that? You can just throw it in your old calculator, see what that is. This idea of building it up, I love. I don't know if you guys like the whole ice cream thing, but I just love this idea of, man, why did you get so many 2's? Why did you get a 5? Of course, Jeff's like, I eat all the ice cream. Ah.
Whining children.
Yeah.
Yeah, man.
They can be a joy, but they can also be
Annoying statement.
annoying. Yes.
Ankle.
All right, that's enough today, I think. So let me know if you have any questions from the test or anything.
Okay, I noticed that I did turn in 3.1 and you did turn it back to me and I got an okay on it.
Okay.
The last time I